Welcome to the Memory Matters Livestream. We are going to learn what two world-class organizations at UW-Madison School of Medicine and Public Health, namely the Wisconsin Alzheimer's Disease Research Center and the Wisconsin Alzheimer's Institute, are doing to protect memories through Alzheimer's research. Tonight, presentations will review a few of the research studies that are already yielding tangible, useful, and practical results that most everyone can choose to incorporate into their daily lives. My name is Steve Ramick, and I'm the Senior Director of Development for the UW Initiative to End Alzheimer's. Tonight, I'm honored to present our speakers. Dr. Nathaniel Chin is an assistant professor in the UW Department of Medicine's Division of Geriatrics and Gerontology. As a geriatrician, he treats patients at the UW Memory Clinics and oversees the clinical care of research participants in Alzheimer's disease studies on campus. In addition, Dr. Chin collaborates with many Alzheimer's disease researchers on campus. Sarah Turner is a UW-Madison alumna and a UW Initiative to End Alzheimer's Board of Visitor member. After serving as a caregiver for her parents, she became involved with Alzheimer's disease research at UW-Madison. Tonight, Sarah will share her personal journey as a caregiver and how that experience led her to actively participate in Alzheimer's disease studies and support research through philanthropy. Dr. Barbara Benlin is an associate professor in the UW Department of Medicine's Division of Geriatrics and Gerontology, and an Alzheimer's disease researcher. Dr. Benlin studies factors that affect brain aging and how they contribute to or protect against the development of Alzheimer's disease. Dr. Benlin and Dr. Chin will highlight some of the work scientists at UW-Madison are doing to help protect memories through research. Dr. Chin is our first speaker. In his presentation, he will help us understand what causes Alzheimer's disease.
Hello, everyone. It's nice to be here in my own home talking to you virtually in your homes or maybe at your places of work. Thank you for that introduction, Steve. I'm here to talk about what is Alzheimer's disease, which sounds like a simple question, but unfortunately it does not have a simple answer. So to begin with, I do like to show this slide. And so you see on the left, for me, when I try to define Alzheimer's disease, I think about it from two perspectives. The one on the left really is the picture of my father, who represents Alzheimer's disease. But obviously a person is not Alzheimer's disease, although those of us who have an affected loved one would say it sure feels that way. Another way of looking at this is that you can view Alzheimer's disease for what it is on the outside. You can see the personality and the physical changes along with the changes that are more typical, the memory and the thinking changes. So in this regard, Alzheimer's disease was the cause of my father's dementia. Now, on the right, though, is the other way of looking at Alzheimer's disease, and that is for what it is on the inside. You can't see that in people who are living in general, and so it is the changes that are occurring in the brain. So Alzheimer's disease is actually this abnormal process of developing two proteins. One is called amyloid plaques that develop outside of the brain cell, and one is called neurofibrillary tangles, or tau, which is a protein that builds up inside of the brain cell. And these two proteins work together to eventually lead to brain cell death. And it is in the brain cell death that we often develop our symptoms and that we see the Alzheimer's disease from the outside perspective. So you can still see these proteins under a microscope, which is what you see in the other figure on the right-hand side. Now, that isn't as important to us when we think about clinical trials, because we don't want to wait for someone to pass away, and we want to get to people earlier and earlier in the course of their disease. And so one of the things I'll be talking about in a few minutes is what scientists are doing to identify these changes earlier and earlier, so that really we can prevent, manage, and cure Alzheimer's disease. So the terms we use can be confusing, and the terms are really important. So the biggest example is that Alzheimer's disease is not the same thing as dementia. Now, dementia is an umbrella term, which really is describing what a person is experiencing or what family and close friends are observing. And there are many causes of dementia, and the ones that are listed here are vascular disease, frontotemporal disease, Parkinson's disease, and Lewy body disease. The most common is Alzheimer's disease. And so while it is the most common, it is still not the same thing. It is really just the main cause of it, and the majority of cases are due to it. So this misconception that we have about Alzheimer's disease and dementia can really lead to unnecessary suffering and to a lack of adequate preparation if you happen to have the diagnosis. And this is particularly true as research is looking at Alzheimer's disease earlier and earlier in the course of the disease. And so dementia is about the person, the whole person. It is the result of the changes that are occurring in the brain that lead to the brain cell death and to the symptoms that come from it. However, the changes are not just memory. Memory happens to be one of them. But in dementia, you have changes in your daily function, your ability to walk or to eat or to do your taxes or to manage your medications. In dementia, there are even changes in your personality that can cause you to be more irritable or apathetic, even feeling sad or anxious. So if you think of dementia as the manifestation of Alzheimer's disease, then you realize we need to not only address Alzheimer's disease, but this process, and also our brains. How can we improve our brain so that it can respond in a different way to the changes that are occurring inside? So as I mentioned earlier, the setting in which we talk about Alzheimer's disease matters. So now in a doctor's office, we define and diagnose Alzheimer's disease based on what we see with the person, so our patient. We look at the outside to make this determination, and we use the history that people provide us as well as their close family and friends, and we do brain testing, pretty extensive brain testing, both in clinic and in research, so that we can determine if someone has normal cognition, mild cognitive impairment, or dementia. Now, the biggest difference between mild cognitive impairment and dementia is daily function. In someone with mild cognitive impairment, they may have symptoms and they may have abnormal scores on their testing, but on a day-to-day level, they're able to perform all the activities that they're used to doing. So once we have this diagnosis, we use the details of the history along with the cognitive testing, along with labs, along with the imaging, to figure out if we think the cause of this condition is Alzheimer's disease or vascular disease or Parkinson's disease. And when we look at that history in particular, we are looking for a decline from a prior level. We're looking for multiple different parts of the brain being affected. We're looking to see that function is affected if it's dementia. But how we acquire that information and the performance on the testing can help us figure out if we think the cause of the condition, dementia, mild cognitive impairment, is due to Alzheimer's disease or not. So in research, Alzheimer's disease is based on what we see on the inside. And so when we start with the brain itself, we can see that there's shrinkage, which is what this figure here shows on the left, a normal looking sized brain and one that has dementia at that point. And you see that it is smaller, in particular the hippocampus, which happens to be the memory center. So in this figure, we're showing someone who most likely has Alzheimer's disease. Now we can identify these changes in a living person. And so that's what the MRI is showing. A regular patient who had this scanned so that we could look for not only blood vessel change, but shrinkage of the brain. And in this particular scan, the person's actually quite healthy and plump and the brain is looking just fine. But really, the problem with this is that this atrophy or the shrinkage of the brain happens very much at the end of the disease course as these changes are happening. And so we really need to go deeper and look at things that are more specific to Alzheimer's and that might occur earlier so that we can have a more meaningful impact. So when we do this, we find out that there are these amyloid plaques and the tau proteins or the neurofibrillary tangles that I mentioned to you. And so these changes are unique to Alzheimer's disease, and they're important in correctly identifying the actual changes in the brain that represent Alzheimer's. So the good news is that with advancements in our technology, we don't have to wait for brain tissue in order to identify these two abnormal proteins. We can actually do that through the study of spinal fluid, which we acquire through lumbar punctures and will do in many of our participants that are willing, as well as amyloid and tau PET scans, which are done to identify the actual protein on a fancy scan, such as a PET scan. So what I'm showing you here are two PET scans. So the one on the left is a amyloid PET scan, and that red color indicates that there's a lot of that amyloid protein. And the scan on the right shows a tau PET scan, which is identifying that tau protein. So this is another way of looking at this, and including time as a factor. And so the first thing that we believe develops is amyloid. So there's an elevated level of the amyloid protein. At some point in time, there is the development of the neurofibrillary tangles or the tau protein. So those are the two things that we are using to identify and define Alzheimer's disease in the research setting. So at this point, it doesn't mean you have symptoms. It's just that we've identified abnormally high levels of this protein. However, at some point when you have these two proteins, there's going to be brain cell death or atrophy. And the scan that you see here is one of an MRI scan or a CT scan that would identify that shrinkage. And usually at that point, there's going to be a development of some symptoms. And that's why I've drawn this green line, because they're crossing over from a research world where we're identifying these proteins into a clinical world where we're starting to hear about symptoms or families starting to report observations of changes in people. And at some point, they're going to get tested, and that's the brain testing or the cognitive testing. Usually it's paper and pencil. And at that point, they're going to show some abnormal scores. So that's how we define mild cognitive impairment. And then this disease will progress, and we notice some functional changes. And that is the end part of this progression, which is dementia. So I like this figure because it shows the overlap of the science and the clinic. And so what we have here is a figure, and on the horizontal axis is age. So you are getting older as you go from left to right. On the vertical axis, you have cognitive function or cognitive ability, and you are losing some of that ability as you go from top to the bottom. And then you see this dark black line going from left to right, and that represents normal aging. And the thing I want you to see is that it's not a straight line. Sadly, as we get older, there are going to be normal age-related changes. And while we don't want that to happen, that is something that we have noticed in our studies and that we experience as we get older. Usually at about the age of 30 to 35, we start to notice some symptoms. Now that doesn't mean that, one, it's not abnormal, but it's also unique to the individual, depending on how you live your life and how you've studied and what the things that you've done. But we know that there are certain parts of the brain that change, and there are certain parts that stay stable. Language happens to be something that stays stable, whereas perhaps processing speed and executive function or the ability to multitask or to remove yourself from distraction, that might start to go down. At the age of 60 to 65, we tend to see more of a unified change. Again, normal, but something that happens to all of us. So while all of this is happening, we have in some people in this abnormal process of Alzheimer's disease, we have this abnormal accumulation of what we call Alzheimer's disease brain changes. That's the amyloid and the tau development. And we know from our studies being done here at UW, that these changes happen 1, 2, 2.5, 3 decades before a person actually comes into the clinic with symptoms. And so this red line represents a deviation from that normal aging progression. And so in this process of Alzheimer's disease, those changes are happening more frequently, more rapidly. They're happening more severely than they would otherwise. And now, of course, if you're going into the clinic along this trajectory, you're going to eventually be diagnosed with either mild cognitive impairment or dementia. Now, this figure here is roughly the same as the one I just showed you, but this one is really trying to speak to the point of what we call a cognitive buffer or cognitive resilience. And we're thinking of this as a mechanism for prevention or delay of these diagnoses and these conditions. So again, on the horizontal axis, you have age. You're getting older, left to right. On the vertical axis, cognitive function or ability. So you're losing some of the abilities as you go from top down. And then now there's a new dotted line, horizontal, that we call the abnormality threshold. Think of this as that green line that I spoke to earlier. You're crossing into a clinical world. Once you go below that line, you're likely being diagnosed with mild cognitive impairment or dementia. And so this is the trajectory for someone who is destined to have Alzheimer's disease. You see that their cognitive ability is declining. However, if there are certain things that person could do in the beginning, middle, and late of their life that might buffer them, that might mean that their brain is stronger and healthier, and they can withstand some of the changes that are occurring from the amyloid and the tau. And so this next line that you're going to see is someone who has higher resilience, someone who has this bigger buffer. And we don't exactly know all the details of that, which is what our center is really focusing on. But we do know, and other centers have shown and supported us in this, that there are certain lifestyle behaviors that can increase one's buffer, meaning that the brain is healthier. Think of it like a muscle, like the way that you would flex your biceps in doing a curl. Well, the more we are challenging our brain in certain ways, in positive ways, perhaps we're strengthening the connections of the brain cells, perhaps we're improving the blood flow. More has to be studied on this, but this is why it's so important that people like Dr. Benlin are exploring, well, what does it mean if we live a certain way or we do certain things? Can we improve our resilience as we're trying to figure out a cure for Alzheimer's disease? Is there something we can do now that can cause us to cross over that abnormality threshold later in life so that we're diagnosed much later, so that our qualities of lives are as high as possible for as long as possible? And so this idea of cognitive resilience and lifestyle intervention, I believe, are going to be discussed with you also by Dr. Benlin, by Sarah Turner, as we explore some of the things that are happening here at the UW Alzheimer's Disease Research Program. All right, thank you.
Hi, everybody. I'm Sarah Turner, and I just wanted to thank Dr. Chin for that fantastic overview for a most complicated disease, and also outlining how Alzheimer's disease can be seen from three perspectives: the personal perspective, the clinical perspective, and also the research biomarker perspective. Just a little bit about my background. I'm here to share with you my caregiving journey with my parents at the end of their lives, how I became involved with Alzheimer's disease research, and how that led me into further supporting UW research through philanthropy. I'm a proud product of Wisconsin public education, K through college. I graduated with a business degree in finance and headed off on a banking career that eventually landed me in New York City for a total of 19 years. My mother never thought I would come home. My mom's journey with cognitive impairment probably started in 2002, 15 years before she died. My sister and I first witnessed significant impaired executive function that we attributed to a combination of stress from my father's fourth major back surgery and abrupt stoppage of her hormone replacement therapy, which was the pretty standard of care at that time. A patient advocacy, which we caregivers are also patient advocates, actually began back in 1996 with my father's third back surgery. I helped him source a second opinion. Dr. Zed Deblick from UW-Madison came to the rescue, and fortunately, his third back surgery was able to reverse the paralysis. Jump forward, in 2007, I decided to relocate back to Wisconsin. I figured that my mom would need some help. By this time, my father, who was 7 years older than my mother, had also lived through colon cancer in 1981 and a massive heart attack and bypass surgery in 2004. Suffice it to say, he was high maintenance. My involvement in their lives first progressed slowly, but then at an accelerating rate, and increased to the point where I was spending virtually every Thursday through Monday in Two Rivers, which, for those of you who don't know Wisconsin geography, is about 150 miles each way. So my car got a good workout. 2 years later, my parents moved into assisted living in Two Rivers, but my caregiving duties didn't end. They just changed in scope. I was still spending virtually every weekend in Two Rivers. Nonetheless, within 11 months, my mom had made 6 trips to the emergency room and spent 3 weeks in skilled nursing rehab. And my father made 2 trips to the nursing room and also had a hospitalization. Within those 11 months, both parents had qualified for hospice, and our collectively family decided we'd move our parents back to their home, the home I was actually born and raised in. And we had terrific support from hospice and a group of private caregivers. Couldn't have done it without these very amazing, generous folks. Moving in as my parents' caregiver proved to be fruitful. Although my physical exhaustion went up, my stress actually decreased, because you're not always hanging out for that phone to ring in the middle of the night, because that's every time it did, I jumped. So it was actually easier to be home. Dr. Chin mentioned in his presentation that the presence of cognitive buffers may also help to postpone onset of cognitive and functional decline. Some cognitive buffers include exercise, stress, management, intellectual stimulation, sleep hygiene, and social interaction. Fortunately for us, my mom loved to walk. And in earnest, she began a regular walking program back in her 50s when we kids left for college. Even as an 80-year-old with cognitive impairment, we would go for 2 to 3 mile walks around town, to the beach and into the woods. I observed that exercise and getting into nature was definitely one of the best cognitive buffers. Not only did it improve her cognition, it kept her muscles from atrophying, it lowered anxiety, and it helped to keep mom on a regular sleep schedule, which is a huge bonus for us caregivers. When the weather didn't cooperate, we also spent lots of time at the local library, Raw West Museum in Manitowoc, and walking around large stores like Fleet Farm. For my mom, it worked better than any prescription medication. Remarkably, she was still venturing outside her home until 4 months before she died, and didn't need to use a wheelchair until the last 6 weeks. We feel pretty blessed about that. Mom was also an avid reader. In the early stages of the disease, we'd take turns reading out loud, and then later I'd read books to her. And as I readied her for bed, I read poetry, especially the works of Mary Oliver, which happened to be really great bedtime reading. I highly recommend. Without my mom's commitment to exercise decades earlier and having the benefit of several other cognitive buffers, I'm not sure that I could have been able to care for her at home. So how did I end up as a research participant? Well, having been intimately involved with my mother's care for the last 10 years of her life and witnessing firsthand the emotional devastation and financial cost, I knew I wanted to become involved with AD research once my caregiving commitment had come to an end. Dementia runs rampant in my family. It not only affected my mom, but her younger sister, my aunt, along with both of my grandmothers. My mother even recalled her grandmother getting funny. Every person in these family slides born before 1950 has either died or will die with significant dementia. The only exception is my dad, who's featured in the black and white photo with the tie. The VA psychologist said my father appeared to have a degree of vascular dementia. He definitely had impaired executive function by the time he reached 90. The emotional cost of Alzheimer's disease is tremendous, especially with so few tools to fight it. It's equally hard to both live with dementia and witness the progression of the disease in loved ones. The financial cost can be equally devastating. Care for someone with Alzheimer's disease, depending upon the location, can easily exceed $100,000 a year, and the average length of life from diagnosis to death is 8 years. It can be a very long journey, and it truly impacts the entire family. Back in the 90s, I was a healthcare banker, and I recall that healthcare expense as a percent of US GDP in the mid-90s was 12%. 25 years later, in 2019, pre-COVID, it had skyrocketed to under 19%. This is going to present a tremendous stressor on Medicare and the healthcare system going forward and for future generations. So I'm even more committed to find a way to help us improve these factors. In any case, for all the reasons I knew I wanted to contribute, I qualified for the Wisconsin ADRC clinical course study prior to my mom's passing. Within 3 months of her death, I was in the initial testing, including an MRI, blood work, a battery of cognitive testing, and a lumbar puncture. Soon after, the ADRC approached me about participating in several different studies, including an intensive lifestyle intervention study that we call BFIT. And Dr. Benlin's going to talk about this when I finish, and I'll try and be brief. This study involved both a change to diet and super frequent aerobic exercise. Fortunately or unfortunately, I qualified. The years of caregiving coupled with timing of menopause put me on a less than healthy trajectory. very common for us women in our 50s. I found the first month of this intervention to be grueling, even more challenging than caregiving, especially the diet portion. Frankly, I thought it was a little nuts, totally unsustainable, and I made my views heard. But I had made a commitment, so I was going to stick it out for the sake of Alzheimer's disease research and to honor my mom and all my friends and parents who've walked this path. Change is hard, but within 4 weeks I had adapted and was starting to realize the results. Nothing like positive results for motivation. Little did I know at the onset of the study that it would change my life. Over the course of 10 months, I lost 36 pounds, woohoo, at this age. My VO2 max, a measure of cardiac health, improved by 33%. And my joints felt better, which was an unanticipated happy surprise. But more importantly, it gave me a superpower. I now felt like I had much more control over my health through optimizing food choices and exercise. It felt like my biological clock had been turned back. What a gift. I've also come to better appreciate that these lifestyle modifications have improved my immune system, making me better able to weather something like COVID should I have the misfortune to be exposed. Anyway, so I'm super grateful. And that whole experience led me to wanting to further support the work of Wisconsin Alzheimer's Disease Research Center and Barb Benlin's work in early identification, lifestyle modification. So on that note, here you are, Dr. Benlin. Thank you very much for joining us this evening.
Hi, everyone. Welcome. And thank you to Dr. Chin for your presentation. And thank you, Sarah, for sharing your story. I'm Barb Benlin, and I am an investigator at the Wisconsin Alzheimer's Disease Research Center. And I'm going to tell you about some of our studies. We're quite interested in modifiable risk factors for Alzheimer's dementia. So there are several factors that we're studying in the lab. Some of these are non-modifiable, and these are shown on the left, and those include things like genetics, having a parent with Alzheimer's disease, age, which is actually the #1 risk factor for Alzheimer's dementia, as well as sex. So women are affected more often than men. On the right-hand side of this slide, we list some factors which are potentially modifiable, which are known to increase risk for later life dementia, particularly if they occur in midlife. And some of these factors are vascular and metabolic factors. We're also studying diet and exercise and gut microbiome. So a few years ago, we started looking at some of these factors, which when they occur in midlife can increase risk for later life dementia. High blood pressure, abnormal cholesterol, central obesity or abdominal obesity, as well as high blood sugar and insulin levels. And we were studying individuals who had a cluster of these cardiovascular risk factors. And when these things cluster, it's called metabolic syndrome. And we compared people with metabolic syndrome to those without metabolic syndrome. And we found that they had lower blood flow to the brain. And those are shown, those regions are shown here in yellow on the slide. We also found that people had slightly lower memory function and that it was partially mediated by that lower blood flow. So based on this, we started a study in collaboration with investigators at the School of Nursing to see whether reversing some of these vascular risk factors in midlife could potentially have beneficial effects. And this was the BFIT study in which Sarah participated. And BFIT stands for Blood Flow Improvement Trial. And this was a 12-week carbohydrate-restricted diet as well as intensive exercise. And I just want to make a comment about diet. We don't necessarily think that there is one diet that's good for the brain, but we did choose the carbohydrate-restricted diet because it's been previously shown to reverse prediabetes or decrease blood glucose levels. So our participants, like Sarah, were recruited from the Wisconsin Alzheimer's Disease Research Center. They were middle-aged, approximately 45 years to 65 years of age. Participants were recruited who were pre-diabetic, so not diagnosed with type 2 diabetes, but had slightly higher blood glucose levels or similar vascular risk factors. And we recruited people who were not already engaged in a lot of exercise, so who were sedentary. We enrolled 29 participants, so this was a pilot study. And shown here are some of the procedures that participants engaged in. So they participated in the carbohydrate-restricted diet, as well as intensive exercise at the UW Natatorium. And measurements were made at baseline, at month 3, and after 6 months. And participants underwent an MRI scan so that we could look at their brain blood flow. They underwent cognitive evaluation as well as blood labs. And shown here are also some of our team members, our staff, and investigators who were involved on the trial. And I have to say that BFIT really was a special study because we had participants like Sarah and other individuals who were from the Alzheimer's Center who came every week to participate in this study. And really there was quite a team spirit together with our staff. So I'm showing you actually here some of our preliminary findings with regard to whether we could alter vascular risk factors through this 12-week intervention. And actually this is the first time that we're showing these findings, and I'm really happy I can share them with you. So first of all, we found that after the 12-week intervention, central obesity significantly decreased. So this is abdominal obesity, and you can see from the first visit shown in pink to month 3, that line shows the average. So the average over the group goes down after the 12-week intervention, and it's maintained until month 6. Blood sugar levels also significantly decreased after the 12-week intervention. Blood insulin levels significantly decreased. Hemoglobin A1C significantly decreased. Triglycerides significantly decreased. And HDL, which is considered the good cholesterol, was significantly increased after the 12-week intervention. We also looked at cognitive function, and we found that cognitive function significantly improved after the 12-week intervention. We saw gains in memory, as well as faster motor and processing speed. We're currently analyzing the brain blood flow scan, so stay tuned, and we'll be able to tell you soon whether we also saw increases in brain blood flow. Now, in addition to the BFIT study, we've been working on other potentially modifiable risk factors, and one of the areas that we've been studying is gut microbiome. And it's possible that some of the beneficial effects of diet could potentially be through effects on the gut microbiome. So what is gut microbiome? That refers to the very small organisms that live in the gut and their associated genetics. There's microbes really everywhere in our environment, but many of these live in and on our bodies. And in fact, there's as many microbial cells in and on our body as there are human cells. And of those, the majority are in the gut. Now, they do important functions related to our health. So they extract energy from the food that we eat. They synthesize vitamins. They play a very important role in immune function. And they also play an important role in maintaining the intestinal barrier. So a few years ago, we published a study on gut microbiome. And we compared individuals who had Alzheimer's dementia to individuals without Alzheimer's dementia. And we looked at gut microbiome, and we found that individuals with Alzheimer's dementia showed decreased diversity of the composition of their gut, so decreased microbial diversity. And we also found that there was differences in terms of the composition. So which microbes were there in the gut differed between people with and without Alzheimer's disease. So right now, we're actually just sort of at the beginning of this research. We don't know exactly how the gut links to the brain, but we have been talking to Sarah, and Sarah made a donation to our research, which allowed us to probe this further. And one of the things we were interested in was whether individuals with Alzheimer's dementia have changes to their intestinal barrier. So do individuals with Alzheimer's disease have increased intestinal permeability? And we also looked at intestinal inflammation. And the way that we did these studies was to look at blood samples that were provided by participants in our research program, as well as look at a protein called calprotectin in the stool of participants who had participated in our research. And higher calprotectin levels indicate higher intestinal inflammation. So what we did was we compared individuals who had Alzheimer's dementia to those without dementia. And then we also looked at a group of individuals who had higher amyloid in the brain, even though they didn't have dementia symptoms. And so that's shown here. You can see the brain that has red. That would be from an individual who has amyloid in the brain. And we call that preclinical Alzheimer's. And what we found was that among individuals who have Alzheimer's dementia or have some amyloid in the brain, that they have higher intestinal inflammation. And we also found that our measures of intestinal permeability were related to the amount of pathology that we saw in the brain. So what I'd like to tell you about this study is that using the funds that Sarah donated, we were able to carry out this study in a smaller number of participants, but it allowed us to generate preliminary data that we used to apply for a grant application from the National Institutes of Health. So this is a good example of how we can use donor dollars to really start a study and then generate some findings that can then be used to apply for another grant. So in summary, there are factors that appear to increase risk for later life dementia. And we talked about a few of those. And when they occur in midlife, they may be especially heightened risk for later life dementia. We don't think necessarily that these types of factors actually cause Alzheimer's disease, but as Dr. Chin described, we think that potentially modifying these factors could delay the onset of dementia and really provide some resilience against development of dementia. And most importantly, Sarah's research participation and her generous gift are helping us make new discoveries that could lead to dementia interventions. So I'll turn it back over to Steve.
Thank you, Dr. Benlin. We have several resources where you can learn about research findings, news, upcoming events, and brain health resources. Dr. Nathaniel Chin hosts the Dementia Matters podcast, which is a great resource for learning about research and caregiver resources. And you can stay connected to the UW Initiative to End Alzheimer's through our social media accounts and our quarterly e-newsletter. There are many opportunities for people to get involved in Alzheimer's disease research at UW-Madison. Our research programs have 2 longitudinal studies, longitudinal Alzheimer's disease research studies on campus, which means people join the study in the intention of remaining part of the study for years or decades. People commit to visiting University Hospital, or in some cases, sites in La Crosse or Milwaukee, every year or every other year. In these studies, people undergo memory testing, physical exams, and brain imaging scans, among other tests. Researchers also conduct dozens of other Alzheimer's disease-related studies on campus each year. These might be shorter studies or particular studies like the BeFit study you heard from Dr. Benlin and Sarah talk about. You can volunteer for studies like these through the Wisconsin Alzheimer's Disease Research Center Research Recruitment Registry. Just about anyone over the age of 45 can join the recruitment registry. Studies look for people with memory issues and healthy memories, and people with or without a family history of Alzheimer's disease. If you are interested in volunteering for research, visit the website on your screen and fill out the Research Recruitment Registry enrollment form. After filling out the form, a recruitment specialist will contact you and speak with you about what study might best fit you. We heard about Sarah's positive experiences participating in research studies and how her generous donation provided valuable funding to help advance Alzheimer's research. Please consider joining Sarah as a memorable friend through a donation to the UW Initiative to End Alzheimer's. Memorable Friends is a community of people who support Alzheimer's disease research at UW. When you become a memorable friend, you support care, education, and future treatments for your friends, neighbors, and families here in Wisconsin. You will help us in the fight to protect memories. To learn more, please visit memorymattersuw.org. Our final segment will be our panel discussion. You will have an opportunity to submit questions to the panel. Please submit your questions in the chat box to be placed in the queue. Our first question that we received: has there been research done on the effects of statins with memory loss?
Hi, everyone. That's an excellent question and a very popular question because statins are so ubiquitous in our medical care and in the community. And so for a long time, there was evidence on both sides, and so people would go back and forth. There was concern that statins caused Alzheimer's disease or dementia, and the most recent review has shown that that is not the case, that statins do not cause dementia. And for those that have vascular changes in their brain, statins in fact can be helpful to people who have the vascular condition. And so as of now, the position is that statins are appropriate for people who have that vascular risk factor, and that we should not be concerned that the statin would actually cause a negative cognitive decline.
Thank you. What would your advice be to a person just starting this caretaking journey with a loved one? Sarah?
Take care of yourself first. If I felt like if I went down, the ship was going down. Decide to cultivate patience. There's so many great resources out there. Dr. Chin's podcast has some great resources out there. The UW, I think it's the WAI, and ADRC also has great resources. There's Alzheimer's.org. They're great books. I mean, y'all can email me. I'm pretty accessible. I can go through my list, specifics. I think get involved early with your loved ones. Cultivate a willingness for you to go with them to the doctor's appointments, so it can be a collaborative effort. Cultivate a capacity to respond and not react. Take deep breaths. Take care of yourself. Take care of yourself. Whatever you do, just take care of yourself.
Thank you. A great question that we received. How long before we will see blood-based biomarkers in a doctor's office? Dr. Benlin?
So there was a lot of interest this year, a lot of news coverage of blood-based biomarkers for Alzheimer's disease. And this is quite exciting because it could be for the first time, the opportunity to have sort of a simple and easy test for Alzheimer's disease that would be related to those pathological proteins related to the disease that Dr. Chin talked about. However, they're still in the research stage. We don't actually know when we're going to be able to have them in the clinic, but it could be a while because they need to undergo further testing and be tested in different populations. And we need to have cutoffs developed as well for what would be an abnormal test and what would be a normal test.
Excellent, thank you. What is the best diet for the brain?
So I can start that one. We don't have a specific diet that we recommend for the brain. Of course, we need to have the studies that really support what would be a diet that prevents dementia. We do suggest that individuals have a diverse diet. There is a diet called the MIND diet that individuals can look up that was developed by Martha Claire Morris. And that's a diet that's very high in fruits and vegetables and whole grains and low in proteins. On the other hand, for our study, we used a carbohydrate restricted diet, which is essentially the exact opposite. But where I'm going with this is that, you know, we need to do kind of larger studies, and it could also be that one diet isn't the best diet for everyone. Dr. Chin, do you have anything to add on that one?
In clinic, I recommend the MIND diet because it is one of the ones that's most studied when it comes to cognition. But along with what BFIT is showing, I also put a caveat into that a low carb diet makes a lot of physiological sense. One of the things that I've come to as I've researched diet with Alzheimer's disease and cognition is sometimes it's about avoiding just the negative things. It's really hard to stick to a particular diet, and it's really hard to know what is the right diet. I think that's an excellent question, whoever asked that. So in clinic, I always say the one thing I can feel very confident about is that no one should drink soda. Artificial sweeteners and soda and that excess sugar. I see Steve kind of moving his head there. This is a really hard thing because it's a part of our culture. But that is something I don't believe anyone would say is good for you and we would advocate for. So I think perhaps it is also about just eliminating some of the things or reducing some of the things that I think common sense tells us we probably shouldn't have a lot of. I'm not against dessert, but maybe not having 3 servings or heaping servings and every night, things like that. But again, the low carb and the MIND diet, I think, are very, very reasonable.
Excellent. Thank you. Thank you. Another great question. Does Aricept 5 milligrams a day help to delay Alzheimer's disease?
Yeah, so that's another really good question. And so Aricept is the commercial name for donepezil. And donepezil is the most commonly used medication to reduce symptoms of cognitive change. And so mild cognitive impairment or dementia. Now, truly, it is meant for people who have already moved into the dementia phase, but commonly we can be using it in people who have mild cognitive impairment as well. Now, the evidence does not support that donepezil or Aricept will prevent the conversion from mild cognitive impairment to dementia. There is a hope that it could delay, very much like that figure I showed about the cognitive buffer. Could it delay the conversion simply because it's reducing symptoms? And that, I think, is still to be determined. But if it could, that is a meaningful outcome for us because it allows people to have their better days for longer periods of time. But so the answer to that is no, it does not delay the development of Alzheimer's, the conversion to dementia. It would reduce symptoms in some people, and if you have dementia, it might reduce or slow the decline, the functional decline and cognitive decline that will happen.
Great, thank you. Sarah, this question's for you. During your time in the BFIT study, you indicated that you had a great experience. What were some of the habits that you took away from BFIT that you still use or implement today?
Absolutely. Well, as Barb mentioned, we had to do a lot of aerobic exercise, like I've never done in my life. And I thought I was pretty healthy before, but no. So one of my mantras is that I need to huff and puff every day. And and that may mean I live on the 10th floor of a condo. That may mean just walking up 10 flights of stairs, but you are huffing and puffing at the end of it. And it may be, and if you see me at Costco, if you see me, a woman doing jumping jacks at Costco when I'm filling up my gas tank, that's me huffing and puffing. I live at the bottom of a hill, downtown Madison, and I try it so I can't breathe anymore up the hill. So, but even just getting out and walking, I think my parents really proved that to me. Oh my gosh, my father with congestive heart failure, the hospice RN said he is a medical enigma. He never didn't get out of bed, which was amazing. But he was just, we did some breathing exercises before he got out of bed. And then he did everything he could to just move his body. And so, I mean, what I do now, because I'm in this position. For me, the whole insulin resistance thing was eye-opening. I say know your markers, get geeky about your numbers, find out how many carbs a day you actually consume. That was mind-blowing to me. I thought I was eating healthy. I was eating organic hummus and pita chips for dinner. Well, it's vegan, it's organic, and it is a disaster from a carbohydrate standpoint. It was a disaster, but gosh, wasn't it good? I mean, I'm also a yoga teacher. I've been teaching yoga since 2002. So, yeah, well, those days are gone. You saw the pictures of my family. My mother, both grandmothers, they were exceptional bakers. Oh my gosh, my mom was cookies after school, bars, brownies, raised dough on Saturday, all from scratch, and a pie on Sunday. I mean, we never not had fresh baked goods in our house. And I had to go through mourning. I mean, literally, I had to go and make peace with not baking, but those products are no longer part of my diet on a regular basis. So the microbiome study is really interesting. I happen to really like to cook. I really encourage everybody to find a way to like to cook and incorporate. I happen to live in a nice condo with an herb garden, and you'll see me going out there, and I'll and then we have 2 different kinds of parsley and basil, and that all counts toward this helping seed your gut with a diversity. Those are the kind of things. And the other thing I really, really encourage everybody to do, it's both Western science, it's also Ayurveda, is stop eating 3 hours before you go to bed and don't eat until the next day. If you can give your gut a break, we all work on alternating current systems. We have the fight or flight and the rest and digest. Our hearts have the systolic and diastolic, and our gut wants a break. So I really, really encourage everybody to give your gut a break for at least 12 hours a day. And maybe some folks occasionally want to stretch it out, like skip breakfast a couple times a day. And it's worked. For 2 years, I've kept the weight off, and I think, again, it's a secret power for me.
That's wonderful. Congratulations. Question for Dr. Benlin. If I was reading the slides correctly, the blood sugar level, A1C, and other tests went down significantly after 12 weeks, but then went up after 6 months. Why?
Right. So what you'll notice is that they did go down after the diet and exercise intervention, and we made those measurements actually right at the end of the intervention. And then participants were encouraged to maintain those habits for the next 6 months. And so there was likely some changes to those lifestyle factors over the next 6 months. So from what you heard, I mean, someone like Sarah really maintained those habits, but we know that behavioral change is difficult. And so some participants probably didn't maintain as long. And this is kind of what we commonly see in diet and exercise type interventions. But in some of those slides, you'll see also that it wasn't that it went up all the way to baseline, but it went up a little bit, but not all the way to where we saw it when people came into the study.
Wonderful. Thank you. This question is for Dr. Chin. During this time of COVID-19, this is a very hard time for caregivers and their loved ones to be together. Do you have any helpful tips that can help a family still stay connected if during this pandemic?
Yeah, that is an excellent question. And the first thing I'll say is for those that have access to my podcast, I have about 6 or 7 episodes related to COVID and either having the disease, Alzheimer's disease or dementia, or being a caregiver. And there are a lot of different resources out there that we're just not aware of. One of the things I would say is that, we are using virtual technology like we're doing right now. And so for those that are able, using Skype or a Zoom or whatever your platform is, being able to connect to people that way is one way, so that you can hear them and you can see them. I still think being able to talk to people on the phone, there have been some really lovely stories in Wisconsin about people writing letters to their loved ones that are in facilities and having someone read that to you. And as tragic as it seems when we see in the news of loved ones outside of windows and looking in, and while that is sad, I still think it is valuable to see the person that you care about, and to, even if you can't necessarily hear them, people who are experiencing changes in the brain, they can still have those meaningful interactions. As a caregiver, it is really important that you have time for yourself. So if you're able to have someone, one of your kids or a friend, use that virtual platform so that you can take a break and do something else, even if it's in the same room, but just not be the center of attention. That is very meaningful for both people. And so for now, that is sort of the what we have. Socially distanced, wearing face masks outside. Some people are doing that too, and you just have to weigh the pros and cons of each of these options.
Thank you. Well, I see we're starting to get a little bit close to time. I wanted to give each of you one last question based on this thought. When you think of memory matters, what does that mean to you in terms of the efforts being done to end Alzheimer's, or the effort? Correct. I'll start with Dr. Benlin.
Well, I will speak more broadly about the Alzheimer's program in Wisconsin, and I am so grateful to all of the participants who have been a part of our research over the years in Wisconsin, and actually some of them have moved out of Wisconsin and continue to be involved. We're just so grateful because really without people like Sarah, we can't make any advances on this disease the way that we do. So we are so grateful for that participation and everybody that's involved in the program.
Thank you. Dr. Chin?
Steve, I missed the question. What was it specifically?
The question is with memory matters. What does it mean to you and the efforts being done to end Alzheimer's disease?
I think of memory matters as it really showcases that it's a two-way street. That research, we need scientists like Dr. Benlin to be doing the nitty-gritty and to develop these methodologies and these studies so that what we say to each other is valid, that these things are real, and then we can prove that through good, accurate science. It takes a long time, right? And so that's one of the things that's frustrating. But this memory matters, and being able to have Sarah on here really speaks to this ability to communicate and talk to people who are invested in this movement. And that's exactly what it is. What is it that you're interested in? How do we incorporate that into the global picture of Alzheimer's research? And how do we share the information immediately that we can share? We can't always share our findings because we're not sure how valid they are. But when they are valid, like Dr. Benlin's today, being able to have this discourse with the community, with people like Sarah, and then get feedback back about it. And so I think memory matters, as Dr. Benlin said, we need our participants, we need our scientists like Dr. Benlin, but we need it to be transparent and we need to work together. And so I'm really grateful for everyone who is here today and for Sarah to be able to share her experience. And of course, for my colleague, Dr. Benlin, to be pushing this field in the right direction.
Thank you. Sarah, same question to you.
Yeah, well, for my participant perspective, such a weird term. Okay, from Two Rivers. Anyway, perspective. I continue to be so impressed with the work that the WAI and the Wisconsin ADRC, Alzheimer's Disease Research Center, does, not just in the research perspective and the clinical, but the work they're doing in Milwaukee, the work they're supporting across the state, setting up Alzheimer's disease specialists across the state. That there's now a person in Two Rivers. There wasn't a person in Two Rivers when I was going through this process with my parents. And it's so comprehensive. It's, again, the UW geriatrics group, amazing. So I'm just in awe at how comprehensive it is. I feel like I'm getting more out of it that I'm even beginning to give to it. And I'm ecstatic to do whatever I can to further the work you guys are doing, because I know it's such good work on such a broad basis across the state for Alzheimer's disease research and supporting caregivers and supporting the families and anyway. So memories matter. Yeah, they matter.
Well, thank you. And then thank you to each one of you for presenting tonight and helping to provide more education to us in regards to the Alzheimer's research happening at UW. Wanted to thank everyone who attended tonight for coming and listening to our presentations. Please watch for an email that will be coming to you, providing supporting information from what you learned tonight in regards to slides, but also hope you consider being a memorable friend and joining us in this movement and helping us support Dr. Chin and Dr. Benlin and others' research and help find a better cure, better ways to help our loved ones through this journey. Thank you so much, and look forward to providing more of these in the future. Have a good evening, everybody.